Assessing normality for population means. Our objective? Determine whether or not a data set can be considered to be normal enough. As we know, we want things to be normal because that way we can make predictions and we can speak to various things about that if they're normal. So what do we know coming in? Well, we know the central limit theorem. If the distribution of a population is unknown or not normal, then the distribution of the sample mean is approximately normal, provided that the sample size is greater than or equal to 30. Mathematically, lowercase n is greater than or equal to 30. So the central limit theorem covers us if the sample size is 30 or above. Okay, we also learned about the normal probability plot. It is a graph that plots observed data versus normal scores. If the calculated critical value, called the correlation statistic, is greater than the critical value given in the table of critical correlation coefficient values table, that's a mouthful, the data are determined to have been taken from a population that is normally distributed. And finally, we know what a box plot is. A box plot is a graph that plots the 5-number summary, and it includes asterisks or maybe dots. I think StatCrunch uses dots for outliers. Okay, so we're assessing normality. Can we consider our data set to be normal or approximately normal? Let's see how that's going to work. Okay. Well, if we are told that the distribution is normal, we're all set. Okay. If we're told it's normal, all is good, and we can move forward with calculating a confidence interval, for example, coming up in future lessons. If we are not told that the distribution is normal, then we can assume normality and thus move forward as if it's normal. If either one or two happens, either one, the sample size is greater than 30, because that's when the central limit theorem kicks in and we can assume normality. Or number two, the normal probability plot, which in StatCrunch is the QQ plot, results in a correlation statistic that is greater than the minimum given in the table, and the box plot in StatCrunch, located under the graph menu Boxplot, doesn't show any outliers. So I guess we have three possibilities. We're told it's normal. Cool, we move forward. We're not told it's normal, but our sample size is greater than 30. Cool, we can move forward. We're not told it's normal, but our QQ plot results in a value we can move forward with, and the box plot doesn't have any outliers, we can move forward. Okay? Obviously, being told it's normal is self-explanatory. The sample size being greater than 30, if you're not told it's normal, is self-explanatory. Number two, we need to kind of do, and I'm thinking at the moment that I might need to get into my, give me a moment here. I'm thinking I might need to get into, I got in there, okay. I think I got in there just in time. Yep, I'm making sure my iPad is not shutting down on me. Okay, let's take a look here at our example. The following data represent the age in weeks at which babies first crawl based on a survey of 12 mothers conducted by Essential Baby. Use StatCrunch along with the critical values for normal probability plots to determine if we can move forward to construct a confidence interval for the population mean. Okay, so we can only move forward if we say it's normal or normal enough. Okay, in our next lesson, we're gonna talk about that. So we look at this, right? We're not told it's normal, and our sample size is not 30. It is it's not greater than or equal to 30. It is less than 30. So we need to check our Boxplot. We need to go to here. We need to check our normal probability plot, our QQ plot, and we need to check the box plot. We need to put the data into, okay, let's put the data into StatCrunch to begin with in order to do that. Let me move this over and we'll pull a couple things out here. Let's first go into StatCrunch. Okay, I think that did I get it? I think I got it. Let's do it here. There we go. I think we're clear. Okay, let me come down to here. Let's put the data in. So I need to 52, 30, 44, 35, 39. So these are what? The number of the age in weeks at which the baby started to crawl. There's my sixth one at 26 weeks, and then we have 47 weeks, followed by 37 weeks, followed by 56 weeks, followed by 26 weeks, and then we got two more, 39 and 28. Okay. Trying to get it to go down here. How do I get that to go down? Not going down. Let's go back into here. Why is that not going down? Put it up there maybe. Nope, it's not going down for some reason. All right. We'll try to move forward with my keyboard where it is. So we're going to first go to graph. There, it went down. Let's go to graph. Okay, I'm not getting graph here. Well, sorry about this, folks. We'll try a refresh. Okay, let's try to go to graph this. There we go, graph. QQ plot is down here toward the bottom. And as a reminder, select our column, which is variable 1, and we want to add the correlation statistic, and we want to check the normal quantiles on y-axis box. Okay, and then we'll press compute. And there we have. Is it normal enough? Is it close enough to this line? We look at the correlation. The correlation says 0.982. Well, we go to our critical values for normal probability plots chart. And for the sample size of 12, it says 0.928. So we are certainly larger. So we are certainly much larger than that, as long as it meets the minimum. That is one test of normality. Okay, so that's good. Let's close that. And now let's check our box plot. So we'll go back to graph, and we'll go to box plot, which is here. And we're looking for any outliers. Okay, our column is variable 1. And I like to draw my boxes horizontally from left to right. I wish they would default to that. Okay, and we have checked use fences to identify outliers, so we're good. Compute, and there's the box plot. And you can see there are no dots or asterisks on either side, so there are no outliers, okay? We can move forward and assume normality. Let's make a note of that here, okay? Let's make a note of what we just found out. So, from our QQ, from our normal probability plot, NOR, let's see if I can spell normal correctly. From our normal probability plot, which in StatCrunch is our QQ plot, right? We got a 0.98, excuse me. Yeah, we got a 0.982 was the minimum. Okay. And the minimum, 982 is what we got. 0.982 was our correlation coefficient. The chart said it needed to be 0.928 or above, so this is the one from the chart. Okay, our correlation coefficient, correlation statistic, is greater than that from the chart. So that means we have normality, or we can assume normality using that standard. And then finally, the box plot. We had no outliers, so we can assume normality here. So back up to here. Let's come up a little bit here. We weren't told it was normal. Whoops, yeah, we weren't told. I gotta make it so you can see that. I'm sorry about that. We weren't told that it's normal. So we had to move down to one of these two. The sample size is not greater than 30. We had to move to this one. We tested the normal probability plot called the QQ plot, and our correlation statistic was greater than the minimum in the table, and we tested our box plot, and we had no outliers. We can now move forward and assume normality, and in this case, with population means, we can begin to build a confidence interval.